with our derivative. Okay, so just now y'all must be wondering, okay, what's the purpose of your differentiation, right? Okay, so one of the reasons why we differentiate, okay, is because the derivative itself, so for any function, okay, so for example, if I have a function maybe x squared, okay, the derivative f prime x, which is going to be 2x, right, will be the gradient of the tangent okay, so it will be the gradient of the tangent to the curve y equals to x squared. Okay, so this is one way that we could interpret, right, for the derivative. Okay, so when we differentiate it, so how do we find the exact gradient? Okay, so you remember last year when we do a lot of graph plotting and all that, I always give you a range of values, right, that will be acceptable for your answers, right? Okay, so how do I actually get the range of values? That is because I can differentiate the function. Okay, but of course there are certain functions that can't be differentiated, right? That one then the teachers ourselves, we will come up with our own marking scheme lah. Okay, other than that, right, most of the functions could be differentiated. So as an A-Math student, okay, you have the skill, right, to actually differentiate the function. Then after that, check whether your gradient value is actually close to the actual answer or not, to the accurate answer. Okay, so if you are able to do the checking, then you will be able to know whether you get the mark or not lah. Right, so that is actually an advantage, right, for you to learn what is differentiation. Okay, so to find the exact gradient value itself, so say for example, if I want to find the gradient, okay, at maybe x equals to 0.1, okay, so I can differentiate already, then I'll get 2x, right? So the gradient itself, that would actually be 2 times 0.1. So I substitute the x to be the given value, okay, of the point that we're looking at. Okay, so this is just a generic equation of the tangents that we could have, alright, on the curve, alright. But then when we substitute in the value, okay, we will be able to get the exact gradient of the tangent. Sorry, let me repeat myself. This one is the equation for the generic equation for the gradients, right? Not the generic equation of the tangent. Okay, so this is only generic for gradients. Okay, anybody lost so far? What do you not understand? So the derivative, okay, this one here is the generic equation for the gradients of tangents. Okay, then in order to find the exact gradient at this particular point, we substitute it into this derivative itself. Then we will be able to get the gradient. Understand? Okay. So let's look at an example to reinforce this idea. So we have a diagram, something like that. Yeah.
For the previous one, right? Do you just give a random number?
This one, I give a random number. This is a random number. Can be negative also. So in this particular question, we are given the graph of this function, and then there's a point A, 213. Okay, we want to find the gradient of the point of the curve at this particular point. So what we have to do in this case, is to first differentiate, the function of the curve. Okay, so part 1, dy over dx, that will give us 6x minus 2 over x squared. okay, because this is 3x squared plus 2x. Okay, so now that you have differentiated it, then at point A, 213, okay, x is equals to 2, so we substitute x equals to 2 to find the gradient. So the gradient will be equals to 11 and a half. Okay. Any questions so far? Alright, now let's look at part 2. Okay, we want to find the gradient of the curve at the point where it crosses y equals to negative x. Alright, so first thing is, how do we find that point? How should we go about finding that point? Benjamin, any ideas? No? We learned it in chapter 1 of A Maths.
Sum in the value of y.
Sub in, right? Okay, it is looking at y equals negative x, so maybe just some line. Okay, so we find the intersection, alright? So we do our simultaneous equation. Remember that? Okay, then after that, we will be getting a cubic equation. How to solve this cubic equation? Use what?
The polynomial that
Okay, we solve by looking at our polynomials, right? So this is a recap of what we learned last year. Okay, so this is a cubic equation. Alright, we want to solve a cubic equation, so we need to first find out what is the linear factor for it, right? Okay, so we will use our factor theorem, or rather press your calculator lah. Okay, so press your calculator to find out, okay, what is one of the factor. So if you press your calculator, okay, minus 1 is a solution. Okay, so we let gx equals to this. So we need to verify this show the working, right? Okay, we cannot just press calculator and say that negative 1 is an answer. No. Right, so when x equals to negative 1 according to a calculator, okay, we apply the factor theorem. So by right, if you press this back into calculator, it should give you 0. Okay, then you need to conclude that x what? Plus or minus 1 will give you, let it be a factor.
Plus.
It should be plus, huh? Okay, so after we find the first factor already, what do we do next? Huh? We need to do long division, okay? So we do our long division, then we can conclude that gx is equals to x plus 1 times the quadratic factor after that, how is it that we can conclude that it crosses these two lines, or rather the line and the curve, they actually cross at x equals to -1. Okay, we need to actually at least mention that since the discriminant since for 3x squared minus 2x plus 2, the discriminant is less than 0 because it is equals to -20. I erase the question. Okay. So since this has for this one, okay, the discriminant is less than 0. Okay, we would find that the line x, y equals to -x, and the curve intersect at x equals to -1 only.
What's the probability again?
Sorry?
For less than 0.
What's the probability?
Property.
Property. If it's less than 0, that means doesn't intersect, right? Okay, because if you remember, that comes from your formula, correct? So if it's inside the square root and it's lesser than 0, you will not find a solution for x, right? Okay.
That means why must we find the discriminant?
Sorry?
Why must we find the discriminant?
To actually say that there is only one intersection. Yeah. Otherwise, if this is more than 0, then there would have been multiple intersections. You understand? Okay. So back to the question, which is to find out what is the gradient, okay, and the gradient at x equals to -1. So the gradient using the derivative that we have done, okay, the gradient will be equals to -8. Any questions?
So you do the long division and the factor theorem, or you just put that you intersect at one point?
Yes. Because we are doing the long division and factor theorem so as to find out where does it intersect. What is the solution? Remember? Try 7. Okay, differentiate this WRT means with respect to. Okay, I will just write it in short in future in order to save time. Okay, so we want to differentiate that with respect to x, and then after that we find the coordinates of the points at which the tangent to the curve is actually horizontal. Okay, so first let's differentiate the function. So let y equals to this. What should we do to actually differentiate this function? What do we need to do first?
Find the close.
Read it out. Huh? Simplify it first, right? You need to simplify it first in order to differentiate it. So we get negative 2x minus 1 over x, which is the same as with x to the power negative 1. Then we differentiate it. And we will get negative 2 plus x to the power negative 2. Okay, so we have done the first part of the question, which is to differentiate it. And then now we want to find the coordinates of the points at which the tangent to the curve is horizontal. Okay, so how do we find the coordinates at which the curve, the tangent to the curve is horizontal? What does it say? What does it mean when we say that the tangent is horizontal? What kind of information can we derive out of this? Gradient will be 0, right? Okay. Okay.